Hi, I'm Alex Russell. I'm a product manager on the Edge team, and my pronouns are he and him. While I'm sad not to be able to join you in person today, I'm delighted to be with you virtually and see just how much the PWA community has grown around the world and in China. As I think about the landscape of PWA's mobile and mini apps, I'm reminded of how and why we began work on PWAs in the first place. Back in 2009, I was part of the Chrome team and was working on a project to develop web components along with JavaScript and CSS language features that we were pretty sure developers needed. At the same time, my colleagues were hard at work on something called Chrome OS. And at the time, there was a debate about what the application model for this new operating system should be. Should it be the web, or should it be something close to the web? Some argued we couldn't evolve the web platform to solve the hard problems that needed solutions, at least not fast enough, and they argued for a separate proprietary platform. Others, like me, argued that we could improve upon the web directly to meet those same needs. And while it might not be as fast, we would gain something profound from that approach. We would preserve the web's distribution model and open development up to a much larger audience of developers. Distribution, in my mind, is the hardest problem in software. And the web's low friction distribution solution for many use cases is incredibly helpful. The alternative, and the path chosen by the Chrome Apps team, was a store-based security approach, rather than the web's more paranoid security by default system. Others were trying the same thing, trying to marry web technologies with a store or installer-based distribution channel that tied distribution to security guarantees, notably the PhoneGap and Cordova projects. There have been many attempts at this combination before and since, including BlackBerry WebWorks, Firefox OS's packaged apps, W3C widgets specification, Palm's WebOS packaged apps, and more recently, the Electron project. All of these systems have in common the idea that it is up to the user at the moment of choosing installation to decide whether or not an application is trustworthy. And they each flip the web's core model on its head, accepting a more difficult upfront step to begin interacting with content in exchange for greater capabilities and some hope that there is security baked in. So back in 2010, I lost the debate, and the Chrome Apps platform launched later that year. In the defense of those arguing that the web couldn't have evolved fast enough, it's safe to say that given the position of the Chrome and Chromium projects in the ecosystem at the time and our relative newness in developing web standards, it would have been unlikely that we would have met their needs quickly enough. But for years following that debate, as we improved our ability to deliver features on the platform, I kept thinking back on the list of features that folks told us the web was missing in order to facilitate the need for an alternative platform. My question was always the same. Could we bring those features to the web without accepting a different distribution model? Or put a different way, could we preserve the power of the link to enable frictionless discovery while still making the web sufficiently powerful for most of the needs that caused folks to reach for native apps or alternative platforms in the first place? If you think about websites as individual apps, it's clear that the web's low friction model was radical at the time it was introduced. By starting with a high-level interoperable system based on standards, browsers have been able to apply increasingly paranoid security that ensures it's always safe for users to tap or click on links to visit another page, or in the parlance of applications, an entirely different app, without gatekeepers mediating the relationship between the user and the publisher. There's no pre-verification going on. There's no content checking. It's just safe to use by default because the platform puts what developers can do in a pretty tight box. This unique property of low friction access has continued even as browsers have grown all manner of powerful new features in the past couple of decades. The difference between the low friction model and the store or gatekeeper mediated model is foundationally a question of power. Who has the power to allow a publisher to create content? And will the runtime those publishers use be powerful enough to service users' needs in the moment? The gnawing questions about which features were missing were in the back of my mind in 2012 when a set of workshops in London began to explore how we might fix the broken design of AppCache, a system for building web pages that worked offline, And app cache was making it difficult to build web apps that were resilient in the face of flaky networks. This seemed like an opportunity to knock off one of the persistent objections from the list. Several years of work followed, including robust collaboration between teams at Google, Mozilla, Microsoft, and Samsung, culminating in the launch of service workers in Chrome in late 2014. While working on this problem, I'd also drafted a short document at Google that outlined how this new service worker system, combined with a small amount of metadata, might enable web apps to become installable. Happily, I soon found out that work had already started on the Web App Manifest project in the standards venues. We would soon have everything we needed for web apps to become first-class citizens on mobile operating systems. With the introduction of Web App Manifests and service workers, for the first time, developers could communicate to the browser that a set of pages were related, that that set of pages could work offline, and could be logically treated as an app. The installation UI that was launched in Chrome for Android in early 2015, and later that year named by Francis Behrman and myself as Progressive Web Apps, was the culmination of an attempt to retrofit those properties that were necessary to upgrade the web's behavior into an existing model that didn't change or require a walk away from the normal operation of links and the way that we deliver web apps. So we had proven that it was possible to make regular web experiences, upgrade them to become installable, and to create standards that enable critical features like push notifications, and do all of that incrementally. Microsoft's introduction of PWAs to the Windows Store in 2017 further demonstrated that we didn't need to give up on the core principles of linkability or a basis in standards to deliver additional reach through store discovery. Finally, web developers could reach all users in a browser, but also those who are searching for their brand or experience in a store. In the years that have followed, we've continued to use the same style and process to pour a long list of new features into the web without the need for gatekeepers, helping developers everywhere deliver experiences through PWAs that maintain incredible reach for developers without sacrificing user safety. Much of this work has happened under the umbrella of the Fugu project, a Chromium collaboration to push the state of the platform forward. If you visit fugu-tracker.web.app, you'll see a long list of features that we've developed over the past few years to expand the power of web apps. This has been an open collaboration, again, between Intel and Google and Microsoft and Samsung and ByteDance and many others, all trying to ensure that we can use the normal standards development process to upgrade what web apps can do without changing the distribution model, without relitigating the power structure such that we give more power to those gatekeepers and take power away from developers. So I tell this rather long story not to bore you with the details of how PWAs came to be, but because I view it as something of a template as we consider PWAs and mini apps together. Like app stores before them, super apps are gatekeepers that manage an ecosystem of content. If a gatekeeper is exceedingly wise, perhaps they can ensure the hurdles that they put in front of developers don't take away more potential commerce from an ecosystem than they facilitate. But it's often the case that successful gatekeepers instead use their positions to entrench dominance and tax developers. It's in this light that I found the past several years of discussions in the W3C and other standards bodies regarding mini apps to be an interesting expression of those very tensions. The Mini Apps Community Group initially formed and produced a white paper in 2019, outlining both the technical differences between mini app runtimes and web browsers, but also the differences in API services and distribution models. Through a dialogue with the W3C's Technical Architecture Group and others working in standards, the document has evolved significantly, but the latest version contains a table that I still find fascinating. It lists very clearly some of the benefits and costs associated more with a distribution model than with the APIs themselves. So from my perspective as a browser maker, it suggests places where I think we as browsers need to become much more open-minded about how we facilitate embedding open web content inside of other contexts, potentially inside of super apps. For instance, what if PWAs were mini apps? I think a lot about these questions in terms of a loop of value that sits at the core of every platform. Platform vendors and promoters build their systems to facilitate the inclusion of services and content in their products that they themselves cannot or will not produce. Those platforms are introduced into the world through products that include them, and platforms succeed if they help developers achieve their goals while simultaneously delivering some value to the product that embeds them. An important property of these systems are the ways that platforms mediate and enable developers in delivering services. And this is the location where platform vendors can levy taxes on developers and the services that they build. Standards often emerge out of the tensions between those parties, as a proxy for resolving tensions in the power relationships that they embody. So in thinking about the future of PWAs and mini apps, I'm mostly thinking about how we can expand PWAs to fit these same needs, particularly to help meet the needs of developers and app providers that are not in the number one position in their respective markets. For those parties, the idea of building yet another mini app for every super app is deeply unattractive. And for super apps that are not in the number one position, it's challenging in some cases to build a large enough corpus of developers who can easily deploy products into their services. It costs a great deal of time and upkeep, as well as coordination, in much the same way that those costs multiplied when developers had to address separate application code bases for Android and iOS. PWAs have helped deliver app portability for developers bringing their experiences to Android, Windows, Mac, and Linux. And my hope is that if we understand the needs of budding super apps and developers, we can set about the same sort of intentional project to close the gaps as we did with Project Fugu, but in areas that are relevant to mini apps. We may already be making more progress on this front than is generally understood. Take, for instance, web bundles. This is work that's been underway in Chromium for the past few years, starting with the launch of a technology called signed exchanges. You can think of signed exchanges as a recording of a single HTTPS request and response pair, and web bundles build on this technology to allow developers to package up many of those individual requests and responses into a single file. The key to this design is that these resources, once they're signed, are understood by browsers as coming from the original publisher's domain, even though they may be sent to the user from a totally different server. That is to say, the web's same origin policy is preserved, even though the server involved may come from a third party. This technology opens up the ability to meet one of the items in the Mini Apps Working Group's list of challenges. And I think that with some creative thinking, we can envision a world of PWAs that could also be mini apps distributed as web bundles. Such a future is, I think, pretty great for developers and good for users. It will allow mini app developers to avoid sinking time and effort into proprietary differences and standardize on common web APIs that might behave slightly differently when their PWAs are experienced in the context of a super app, but not a browser. But those differences don't require us to perpetually contemplate a separate development team or separate deployment mechanism for each combination of service and entry point. So that's it. That's my vision. A world where browser makers can listen humbly to the needs of super app makers and mini app developers and work to intentionally close the gaps so that the web can simply be the platform for mini apps. We have some precedent that it can work because we've done it before with PWAs. I'm optimistic that it'll work again if we try. Thanks so much for inviting me, and thanks to the organizers for putting on such a compelling day of content.